One of the ways that we control scatter radiation is through the use of grids. The purpose of a grid is to remove any X-rays that are not traveling in a straight line from the tube. We can reduce scatter by up to 97% or more, but it comes at a cost, an increased technique. Grids are already all around us. Your equipment, such as a table or wall bucky, could have a grid either permanently installed or give you the ability to swap out different types of grids depending on what you're going to image. You will also use grids when taking portables. These grids fit on top of the image receptor. Grids come in all sorts of sizes, material, and types. Every grid should have a label indicating what type of grid it is: the grid frequency, or the number of lead lines per centimeter, the grid's ratio, the SID or focal distance that the grid should be used at, and possibly the material it's made from. At its most basic level, a grid is alternating pieces of radiopaque material such as lead and a radiolucent material such as aluminum or plastic fiber. When we discuss grid ratio, it is the height of the grid to the distance between each lead strip. Grid ratios range from 5:1 to 16:1. A 5:1 grid will remove 85% of scatter radiation, whereas a 16:1 grid will remove 97% of scatter radiation. However, the higher the grid ratio, the greater your technique must be. The 8:1 grid is typically the most common and is usually in most table buckies. The 16:1 grid can typically be found in your dedicated chest bucky. The grid frequency is the number of lead strips per centimeter. Most grids are about 25 to 45 strips per centimeter. A high-frequency grid will show less grid lines. However, a high-frequency grid will need a higher technique. There are four types of grids: parallel, crossed, focused, and moving. A parallel grid will have lead strips that are lined up with each other. The main advantage of a parallel grid is that it is cheap to produce. Three disadvantages of a parallel grid are that it requires a long SID, it requires a small image receptor, and you inherently get grid cutoff. Grid cutoff is when the primary beam is absorbed by the grid. You can see on this image that only the primary beam closest to the central ray is making it through the grid. A crossed grid will have two parallel grids stacked on top of each other to form a matrix. The main advantages with a crossed grid are that they are cheap to produce and they're better than a parallel grid. For example, a 6:1 crossed grid is better than a 12:1 parallel grid. The three disadvantages of a crossed grid are that positioning is critical, you'll need a substantially higher technique, and you still get grid cutoff. A focus grid has lead strips that are lined up with the anode target. The advantage of a focused grid is that you get no grid cutoff. A couple disadvantages of a focus grid are that they are harder to manufacture, so they're more expensive, and they require an exact SID. Finally, we have a moving grid. It's basically a parallel crossed or focus grid that quickly vibrates back and forth. These grids are normally found inside your table and wall bucky. The advantage of a moving grid is that you will get no grid lines, but the disadvantage is that it requires a bulky mechanism to move the grid back and forth, which is capable of malfunctioning. There are four main types of grid errors. They are off-level, off-center, off-focus, and upside down. An off-level grid error is caused when the grid is not perpendicular to the central ray. This causes grid cutoff. An off-center grid area is perpendicular with the central ray, but it is shifted laterally. This causes grid cutoff. An off-focus grid area is perpendicular with the central ray, but the SID does not match what is required for that grid. This causes grid cutoff. Finally, an upside-down grid area is perpendicular with the central ray and is positioned properly. However, it was placed upside down. This too causes grid cutoff. Anytime you use a grid, you will need to increase the technique significantly. For an example, if you shoot an image with no grid at 10 mass and 100 kVp, and then you decided to shoot that image again with an 8:1 grid to reduce scatter, you would need to either multiply that original mass by 4 or add 13 to 15 kVp. That means your new technique would either be 40 mass at 100 kVp or 10 mass at 115 kVp.